A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headache.
If you're building anything with AI, check them out. Modal.com. Alright, we are diving into the copper and glass today. Today's prompt from Daniel is about the perennial headache of the home audio enthusiast, the cable chain. He's looking at a setup with a mini PC, a DAC, and some powered speakers, and he's caught in that classic choice paralysis between USB, TOSLINK, RCA, and the beefy XLR connectors. It's one of those situations where you have 4 different ways to connect 3 boxes, and every forum on the internet tells you a different correct way to do it.
It is a phenomenal rabbit hole, Corn. Honestly, people spend thousands of dollars on cables that provide zero measurable improvement, while ignoring the $5 fix that actually solves their noise floor issues. By the way, for the tech curious out there, today's episode is powered by Google Gemini 1.5 Flash. It's helping us navigate the signal-to-noise ratio of this discussion. It's funny because we're talking about physical cables while being powered by an AI that essentially lives in the cloud. But even that data has to travel through massive undersea fiber optic cables to get to us. Everything comes back to the physical layer eventually.
I love that we're starting with the mini PC variable, because those things are notorious little noise boxes. You've got high-density components, switching power supplies, and often a lot of electronic chatter right next to your sensitive audio bits. If you've ever opened one up, it's a miracle they work at all. Components are packed so tightly that electromagnetic interference is just bouncing off the walls. Daniel is asking about the first link in the chain, PC to DAC. Should he go USB or TOSLINK? Herman, I know you have thoughts on the optical is better because it's light argument.
The light is pure. Argument is one of those half-truths that drives engineers crazy. Let's look at the physics. TOSLINK, or optical, uses plastic fiber to transmit data as pulses of light. The massive, undeniable advantage here is galvanic isolation. Because there is no metal wire connecting the PC to the DAC, there is no electrical path. That means ground loops, that annoying 60 Hz hum or the chirping you hear when your PC's graphics card starts working, are physically impossible. If you have a noisy PC, TOSLINK is a literal circuit breaker for interference.
Can we pause on that chirping for a second? I think a lot of people think their speakers are broken when they hear that. You know, you move your mouse across the screen and you hear a little zip-zip in your headphones.
That's rarely the speakers. What's happening is that the power draw from your CPU or GPU is fluctuating. Those fluctuations create tiny changes in the ground voltage of the motherboard. If you're using a USB cable, that dirty ground is physically connected to your DAC's ground. The DAC then amplifies that difference right along with your music. It's essentially the PC's thinking, translated into audible noise. TOSLINK solves this because, well, you can't send an electrical ground through a piece of plastic.
But wait, if TOSLINK is so perfect at stopping noise, why do we even use USB for audio anymore? If I can just cut the electrical connection entirely, shouldn't that be the default for everyone?
You'd think so, right? But TOSLINK has a very low glass ceiling, or plastic ceiling I should say. Think of it like a narrow hallway. You can only fit so much data through it at once. Most TOSLINK ports are limited to 24-bit 96 kHz or maybe 19.2 kHz if you're lucky. USB is like a 12-lane highway. It can handle 32-bit 768 kHz and DSD files that would make a TOSLINK cable choke. Plus, there's the issue of the conversion process itself.
You mean the double flip of the signal?
Your PC has to take the electrical signal, turn it into light pulses using an LED, send it down the fiber, and then the DAC has to turn those light pulses back into electricity. Every time you convert energy from one form to another, you introduce the potential for error. It's like a game of telephone where you're translating between two different languages in the middle.
Okay, so TOSLINK wins on noise. But I've heard you grumble about jitter before. Is it true that optical is actually blurrier for the data?
In a sense, yes. With TOSLINK, the clock signal, the heartbeat that tells the dock when to convert each sample, is embedded in the data stream itself. The dock has to recover that clock by looking at the edges of those light pulses. Because plastic fiber, which is what most TOSLINK cables are made of, is relatively low quality compared to glass fiber, the light pulses tend to smear or spread out as they travel. This makes it harder for the DAC to tell exactly when a pulse starts and stops. We're talking about jitter in the range of 3 to 5 picoseconds in a modern 2026 era DAC. Now, compare that to asynchronous USB. In a USB setup, the DAC is the boss. It has its own high-precision internal clock and tells the PC, hey, send me data only when I ask for it. That pulls the jitter down to maybe 1 or 2 picoseconds.
Wait, so we're choosing between a tiny bit of timing error with TOSLINK or a potential giant buzzing hum with USB. That sounds like a pick your poison scenario. Is there a middle ground?
Well, the middle ground is usually a better USB cable, not an expensive one, but one with a decent ferrite bead or a USB decrapifier, which is a real term for a galvanic isolator, but those can cost $100. If you're Daniel, you have to ask, can I even hear a picosecond? To put that in perspective, a picosecond is 1/trillionth of a second. The speed of light is about 300,000 kilometers per second. In 1 picosecond, light travels about 0.3 millimeters. That's the thickness of a few sheets of paper. We are talking about timing errors so small that the physical movement of your head by a fraction of a millimeter while listening would cause a larger phase shift than the jitter in the cable.
That's a great analogy. It puts the audiophile panic into perspective. So for Daniel, if he's sitting there with his mini PC, the play is probably to start with USB. If he hears high-pitched whining when he moves his mouse or a low hum, then he swaps to optical and accepts the bandwidth limit. It's basically a diagnostic tool as much as a connection.
Precisely. And let's talk about that bandwidth limit, because it's a real hard ceiling. TOSLINK was designed in the 80s for CD players. It usually tops out at 19.2 kilohertz. If Daniel wants to play super high resolution DSD files or 384 kilohertz PCM, the kind of stuff you get from high-end streaming services or master recordings, TOSLINK just can't carry enough light to make it happen. You'll get silence or stuttering. USB, on the other hand, is basically a wide open highway. It can handle 32-bit audio at 768 kilohertz without breaking a sweat.
Is there any risk of the USB cable itself acting as an antenna? I've seen those cables with the big lumps near the ends.
Those are ferrite beads. They are actually very useful for Daniel's mini PC setup. They act as a high-frequency filter that suppresses electromagnetic interference. It's a passive way to clean up the line without needing a $100 isolator box. If he goes USB, he should definitely look for a cable that has those. It's a $2 feature that actually does something measurable.
So USB is the performance choice. TOSLINK is the safety choice. Now, once we get the signal into the DAC, it's converted to analog. This is where the last mile to the speakers happens. Daniel is looking at 3.5mm versus RCA. I've dealt with enough tangled messes behind desks to know these are the two most common sites. But they aren't created equal, are they?
Not at all. Honestly, the 3.5mm jack is the bane of my existence. It's a miracle of miniaturization, but it's a disaster for long-term reliability. Think about the geometry of a 3.5mm plug. You've got 3 separate contact points, left, right, and ground, all crammed onto a tiny tip ring sleeve connector. The actual surface area where the metal touches is tiny. If you wiggle it just a hair, or if a bit of dust gets in there, you lose a channel or get a static pop that could blow a tweeter.
I've had that happen. You're reaching behind the PC to plug in a thumb drive, you bump the 3.5mm cable, and suddenly it sounds like a gunshot went off in the room. It's terrifying.
It's the lever effect. Because the plug is so long and thin, any tug on the cable applies a lot of force to the internal spring contacts of the jack. Over time, those springs lose their tension. RCA is just its big boy hardware. You have separate physical cables for left and right. The contact surface area is huge by comparison. The outer ring of an RCA plug grips the sleeve of the jack with a lot of tension. It's a much more robust mechanical connection.
Is there an actual sound quality difference, though? Or is it just about the plug not falling out?
There's the crosstalk issue. In a 3.5 millimeter cable, the left and right wires are running nanometers apart inside a single jacket, often sharing a very thin braided ground wire. That creates electromagnetic coupling. As the signal travels down the wire, the magnetic field from the left channel can actually induce a tiny voltage in the right channel. You might get a tiny bit of the left channel bleeding into the right. With RCA, because they are physically separate paths, often with their own individual shielding, your stereo separation is measurably better. We're talking about a noise floor difference of maybe 5 to 10 decibels in terms of channel isolation. In a high-end system, that's the difference between a wide soundstage and one that feels a bit cramped in the middle.
Does the length of the RCA cable matter for Daniel? He's on a desk, so he's probably looking at what, 3 feet?
At 3 feet, it's negligible, but if he were running 10 or 15 feet, that's where RCA starts to struggle. RCA is an unbalanced connection, meaning the shield of the cable is also part of the signal path. It's basically a giant antenna. If you have a long RCA cable running parallel to a power strip or a bunch of monitor cables, it's going to pick up a 60 Hz hum like a sponge. On a desk, it's fine. Across a living room, that's where you start having problems.
Which leads us perfectly into Daniel's curveball, XLR. Everyone sees those chunky 3-pin connectors in recording studios and assumes they're the gold standard for sound quality. They look like they could survive being run over by a tank. Does a balanced XLR connection actually sound better than a short RCA run on a desk?
This is where the marketing hype hits the brick wall of physics. Balancing is a brilliant piece of engineering called common mode rejection. To understand why it exists, you have to realize that every cable is essentially an antenna. It's picking up radio waves, Wi-Fi signals, and the magnetic hum from your power strips. An XLR cable carries 3 wires, a ground, a hot signal, and a cold signal. The cold signal is just the hot signal flipped upside down, a mirror image.
Right, and here's the magic trick. Any noise that leaked into the cable during the trip hit both wires equally. It's not like the noise knows which wire is which. It just lands on the whole cable like rain.
So when those 2 signals reach the speaker's input stage takes the cold signal, flips it back over, and adds it to the hot signal. Since the music was mirrored, flipping it back makes it in phase with the hot signal, so they combine and get stronger. But the noise? Since the noise was the same on both wires, flipping one side makes the noise on that wire the exact opposite of the noise on the other. When you add them together, the noise cancels itself out to 0. It's like noise-canceling headphones, but for a wire.
It's beautiful. But I feel but coming. If it's so perfect, why shouldn't Daniel just use it for everything?
Because it only matters if there is noise to cancel. If Daniel is running a 1-meter cable from his DAC to his speakers on a wooden desk, there isn't enough interference to matter. The noise floor of an unbalanced RCA run in a typical room is about minus 90 decibels. That's already quieter than the ambient noise of a library. Balance might get you to minus 110. But your speakers probably have an internal noise floor of minus 80. You're solving a problem that the rest of your gear and your ears can't even detect.
So if he's using active speakers that have XLR inputs, is there any harm in using them?
Not necessarily harm, but potentially wasted money. And there's the gain issue. Balanced connections usually output at 4 volts, while RCA is 2 volts. If Daniel plugs in via XLR, the music will be significantly louder at the same volume knob position. This is a classic trap. He'll think, wow, the XLR sounds so much more powerful, but he's really just hearing a 6 decibel volume boost. If he matched the volume levels exactly, that power would likely vanish.
That louder is better. Trap is so dangerous. If Daniel plugs in XLR and thinks, wow, this has so much more bass, he's probably just hearing the 6 dB gain boost. If he turned the volume knob up on the RCA connection to match the level, they would likely sound identical.
Precisely. If you don't level match your tests with a decibel meter, you're just measuring your own psychoacoustic bias. And there's one more technical gotcha for Daniel. Just because a device has XLR ports doesn't mean it's truly balanced inside. This is a huge buyer beware in the audio world. Some budget DACs just take an unbalanced signal, run it through a cheap op amp to invert the phase at the very last second, and slap an XLR connector on the back for show.
Wait, so the internals are still just RCA-style circuits, and they just added the fancy plug at the end?
To get the real benefit, lower distortion, and higher dynamic range, the entire internal circuit from the digital to analog chip all the way to the output has to be doubled. You need 2 separate signal paths for the hot and cold signals for every channel. That's twice the components, which is why true, balanced gear is so much more expensive. If the internal circuitry isn't balanced, using an XLR cable is just adding extra metal and complexity for no reason. It's like putting a spoiler on a car that can't go over 40 miles per hour.
That's a massive point. How is Daniel supposed to know if his gear is truly balanced? Is there a label or something?
Rarely. You usually have to look at internal photos of the circuit board. If you see 2 of everything, 2 sets of capacitors, 2 sets of resistors for each channel, it's balanced. If you see 1 set of components leading to both the RCA and XLR jacks, it's a fake balanced output. It'll still work, and it'll still reject noise in the cable, but you won't get the inherent distortion canceling benefits of the balanced circuit itself.
So, let's tie this together for Daniel's specific setup. He's got the mini PC, the DAC, and the speakers. If I'm him, I'm going USB from the PC to the DAC first. It's the most modern, highest bandwidth option. It handles the high-res files he might want to play, and the DAC's internal clock will keep things tight. If, and only if, he hears that high-pitched computer screeching when his CPU is under load, he switches to a TOSLINK cable. Those are cheap, like $10 for a decent one.
And for the analog side, skip the 3.5mm to RCA adapter if possible. Those adapters add 2 more mechanical junctions where things can go wrong. If the speakers have RCA inputs, use a dedicated RCA to RCA cable. It's mechanically more stable and provides better channel separation. As for XLR, unless he's planning on moving those speakers 10 feet away or he's living inside a literal radio tower, RCA is perfectly fine. The money he'd spend on fancy XLR cables would be much better spent on a thick rug for the floor or some acoustic foam for the wall behind the speakers.
Room treatment, the least sexy but most effective cable you can buy. It's funny how we obsess over picoseconds of jitter or the metallurgy of a copper wire while our rooms are creating massive echoes and standing waves that last tens of milliseconds. We're worried about the plumbing while the roof is missing and the windows are broken.
It's the audiophile's paradox, Korn. We want to control the signal because the signal is easy to buy in a box. You can order a better cable on Amazon and feel like you improved your system. Controlling the air in the room is hard work. It involves moving furniture, measuring frequencies, and maybe putting ugly panels on the walls. But if Daniel follows the USB to RCA path, he's already at the 95% mark for audio fidelity. Everything beyond that is diminishing returns.
What about the gold-plated factor? Daniel is going to see cables ranging from 5 to 500. Is there any reason to go above the basic but well-made tier?
Gold is great because it doesn't corrode. If you live in a humid environment or near the ocean, gold plating on your connectors will keep them from oxidizing over 10 years. But does it conduct better than copper? No, it's actually worse. Silver is the best conductor, followed by copper, then gold. We use gold for longevity, not for speed. A $20 cable with solid connectors is going to perform identically to a $200 cable in a blind test 99.9% of the time. The only thing you're paying for in the expensive cable is the jewelry factor. The nice braided sleeve and the heavy metal housings.
I remember seeing a study once, and this might be an urban legend, where they tested audiophiles with a coat hanger versus an expensive speaker cable.
It's not an urban legend. It was a blind test done by the Monster Cable forums back in the day. They used a set of coat hangers twisted together as the cable and compared it to high-end Monster cables. The experts couldn't tell the difference. Now, I wouldn't recommend using coat hangers because they have terrible shielding and they'll rust, but it proves the point. The physics of carrying an audio signal over a short distance is remarkably simple.
So the takeaway for Daniel is, don't overthink it. Start with the most logical physical connection, USB and RCA. If there's no noise, you're done. If there is noise, diagnose it. Don't throw money at premium. Copper hoping it will fix a ground loop.
And remember, the goal is to listen to the music, not the equipment. If you find yourself listening to a track just to see if you can hear the blackness of the background between notes, you've stopped being a music lover and started being a hardware tester. Daniel should set it up, make sure there's no hum, and then forget the cables even exist.
Well said. I think we've successfully demystified the cable chain for Daniel. It's really about matching the interface to the environment, not chasing some mythical pure signal that costs more than the speakers themselves.
And if he ever upgrades his speakers to something massive that sits across the room, then and only then should he start looking at those chunky XLR cables. Until then, the desk setup is a much simpler beast.
If you're enjoying these deep dives into the weeds of tech, you can find us at myweirdprompts.com. We've got the full archive there, including some of our older explorations into the science of digital to analog conversion, though we've learned a lot since those early days in the 2020s. We're constantly updating our own internal firmware as the tech evolves.
We really are. It's a fast-moving world. Big thanks to our producer, Hilbert Flumingtop, for keeping the signal clean and making sure our levels are perfectly matched so we don't fall into that louder is better trap ourselves. And a huge shout out to Modal for providing the GPU power that keeps our AI brains humming along at high sample rates. Without that compute, we'd just be a bunch of unorganized data packets floating in the ether.
If you've got a second, leave us a review on Apple Podcasts or Spotify. It actually helps more than you'd think to get the show in front of other curious minds who are currently arguing about cables on some forum at 3:30 a.m. Let's save them some money.
Let's bring them into the light, whether it's TOSLINK light or just the light of reason. This has been My Weird Prompts. We'll catch you in the next one.
Stay grounded, Daniel.
See ya.
This episode was produced using Google Gemini 3 Flash, text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow to